Okay, our second lesson is on 1-2, and it's on points, lines, and planes. And there's actually several different learning goals that we're going to address in this lesson, and we're actually going to focus on all these different learning goals over the next several lessons. So a lot of these will seem like, oh, we already did that learning goal, but it applies in different ways. So in your Cornell notes, how about if you just put in the date, put in the title, points, lines, and planes, and then where it says, where you usually put your essential question or your essential understanding, maybe just indicate that we're going to talk about, I think it's learning goals 2, 3, 4, and 5. But make sure you double check that against your handout of your learning goals. So maybe just write that instead of writing out all of the language for every single one of these learning goals, because it's right there on your sheet. I don't think we have to write this over again. But in this lesson, we're going to focus on understanding and using the basic terms of geometry. We're going to understand how to use correct naming conventions. So naming conventions is kind of like the way that we label things and the way that we name figures. And we have certain symbols that we use when we're talking about the name of a figure. We're also going to identify and describe the relationships of figures in two-dimensional and in three-dimensional space. And then finally, in this lesson, we're going to start to understand, explain, and apply the 4 basic postulates of geometry. And we'll talk about what a postulate is later on in the notes here. So let's get started. The first thing that I want you to do before you take these notes is kind of think about these 3 things: point, line, and plane. And so in class, what we did is a quick write. So if you just want to stop and pause for a minute, give yourself about 3 minutes. And on the left-hand side of the page where we process, I want you to try to write down what you think a point is, what you think a line is, and what you think a plane is. And try to put those ideas into your own words. Okay, so after you've hopefully paused and started back up again, and thought about what a point is and a line and a plane, let's actually talk about their specific definitions. Now, a point is kind of weird. We say that a point has no dimension. So let's think about what I mean by no dimension. There's 3 dimensions, right? In the 3 dimensions, there's length, width, and height. So if a point has no dimension, that means it has no length, no width, and no height. So if it doesn't have length, width, or height, what does it have? I think the best way to think about a point, and maybe write this in here as well, is to think about it as a location. So we'll write that down. Think about a point as a specific location. So you learned about points in algebra when you graphed, right? So for example, here's the x-axis, here's the y-axis, and here's the coordinate 3, 2, right? That's a specific location on your graph. So in geometry, points are no different. You just have to recognize that they're actually really, really tiny. They're infinitely small. They have no size at all. Now, when we're naming points, like we have here in this example, we have point A. And when we're naming them, we always name, we always name them with a capital letter and a single capital letter. So here we have point A, maybe over here we have point B. We draw a dot so that we can see that, yes, we're actually talking about a point, but we name them with a capital letter. Now in your Cornell notes, I want you to be thinking about some level 1 questions that should go along with the information. So here, this first one would be maybe what is a point, or maybe how can you describe a point? And then another one might be how can you name a point? And this is that naming convention piece, or that labeling, so we label things correctly. So the second thing we talked about is a line. And if a point has no dimension, then we say a line has 1 dimension. It might have only length, for example, but it doesn't have width and it doesn't have height. So that means it's like so skinny you can't even really see it. So it has that 1 dimension length And then that length extends without end in two directions. That means that your line goes on forever and ever and ever and ever and ever. Now the way that we represent a line, when we draw it, we're going to draw a straight line like you see right here. A straight line, and at the end of the line we're going to put two arrowheads so that we know it extends forever and ever and ever. When we're naming a line, there's two different ways that we can name a line. The first way that we can name a line is by using 2 points on the line. So for example, this line that we see here we might call line AB, and then we would put an overbar on top of AB with 2 arrows. And that's the correct symbol to tell me I'm talking about a line as opposed to something else. Now for this particular line, we could also call it line BA. The order of those points does not matter. The second way that we can name a line is with a small italic letter near the line. So it's hard to write in italics, so I just try to make sure it's kind of curvy when I actually write it, like I would do an M like that. And it's always, 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 let's add this in our notes, it's always lowercase. So when we talk about points, we use capital letters for our points, but we use lowercase letters to name lines. And that's an important difference because it helps me figure out, well, when I see that letter, I know, oh, that's talking about this line, not another point that may be near it. Okay, so we use a small italic letter, so we could call this line M. One thing that we don't do ever is we don't use 3 points to name a line. So don't ever do this. Like let's say there was a C there. We would not call this line ABC or ACB or anything like that. It's only just 2 points on the line. So think about your level 1 questions and then maybe develop them a little bit further. But one might be describe a line. One might be how do you name a line? Okay, the third thing that I asked you to think about was a plane. And what is a plane? We say a plane has 2 dimensions. So maybe it has length and width, but not height. So here it might have length, it might have width, but it has no height, so it doesn't really have any thickness. We usually represent it by a shape that looks like a floor or a wall or a tabletop. Any kind of flat surface is something that does a good job representing a plane. The only thing is that if you think about a wall has a top and a bottom, and a plane extends without end. Just like a line keeps on going forever, a plane keeps on going forever as well. So it keeps on going up and down and to the left and to the right. When we draw a plane, we usually draw it like a quadrilateral or a parallelogram like this. So don't just draw a rectangle for a plane. If you draw it as a parallelogram or a tilted rectangle, it kind of looks like it has more dimensions so that it's in space, not just like this flat little rectangle. The way that we name a plane is, again, we have 2 choices, just like with a line. We can either name it with 3 points that are on the plane, but they can't be all on the same line. So notice how in my picture here, C, D, and E form a triangle. They're not all 3 of them on the same line. That's good. That means that I can use those 3 points to name my plane. So I could call this plane C, D, E, for example. The other way I can name it is with 1 capital letter that's usually somewhere in the corner of the plane, but it's not naming a point. That's just like the capital letter M. You can see how there's no red dots anywhere near it. So we could also call it plane M. So for your questions on the left here, describe a plane, how do you name a plane, and maybe even how do you draw a plane, because I think that's really important. Okay, so you're not in the classroom probably right now, but maybe in whatever room you are, just kind of look around the room and see if you can name some things that might represent points, lines, or planes. So we already talked about planes, for example, might be like the wall or the floor or the window. Points might be like the corner of a desk or the tip of your pencil, or I don't know, the corner of just about anything is a good representation of a point. A line might be represented by anywhere you have, maybe you see a crack somewhere, like if we have the brick walls here at school, the cracks running through the brick walls, or the edge of the poster board, or the corner where the wall meets the ceiling could be representing a line. So those are just some examples to think about. Okay, a couple more vocabulary words. First one is collinear. And if you look at the root word of collinear, the root word here is line. We have co in front of it. Co means together. So we think about together on a line. So collinear points are points that lie on the same line. So if you look at this diagram, we have two intersecting lines. We have a line here and we have a line here. In fact, you might say line LN and line OM, and they intersect at M. That would be one way you could say that. Now, if I'm looking at line LN, there's lots of different ways I could name that line. That's just how I chose to name it. But if I want to find some collinear points, there's only 3 points that I see that are all lying on the same line. So in this example, I would say L, M, and N are collinear. Another thing that I could say is that if points aren't collinear, we call them non-collinear. So I could say O, N, and P are non-collinear. Just like collinear, we also have coplanar. And the root word of coplanar, of course, is plane. So this has to do with being on a plane. So coplanar points or lines are points or lines that lie on the same plane. So if you look at this example here, I know that reading these diagrams can be somewhat confusing sometimes, but here we have plane T, and points B, A, and C are on plane T. So AC, line AC, is also on plane T. However, line QR is going through plane T. So it's kind of like plane T might be represented by the top of your table, but line QR is going straight down through your table. So in this particular picture, points B, A, and C, those points are coplanar. However, maybe points Q, C, B, and A are non-coplanar because they do not all lie on the same flat surface. So a couple of questions that you might write here. What does it mean to be collinear? What does it mean to be coplanar? Okay, now we got to talk about the first 4 postulates. And the first 4 postulates are actually the fundamentals of geometry. Everything else is based off the fact that these things are true. So before we talk about those postulates, we should probably talk about what that word postulate means. And a postulate is something that we believe is true, but we can't prove it. So here's an example. Through any 2 points, there is exactly 1 line. Or another way of saying that is that 2 points determine a line. 2 points tell us where that line is, and there's only 1 line that goes through those 2 points. So in this case, in this picture that we see here, line N is the only line that goes through P and Q. And of course, another way that I could name this line would be line PQ. Now this is actually really important because if there's only 1 line that goes through 2 points, it tells us something about what lines look like. It means that lines have to be straight. So, for example, I could draw another line like this that went through P and Q, but that line is curved. And so what we're saying here is that if there's only one line that goes through 2 points, we wouldn't consider something that's curved like this. We wouldn't really call it a line. We'd have to call it something else, like a curve. Get rid of that. All right, the next postulate is this. If 2 lines intersect, then they intersect in exactly 1 point. And that's also like what we just looked at. If I had 2 lines where one was straight and one was curved, they would intersect in more than 1 point. So this also tells us that lines have to be straight and that they cannot be curved. So here we have line K and line M intersect at A. Or point A, you might write as well. All right, our third postulate. This one's a little bit trickier because now we're looking into 3 dimensions. And it says that if 2 planes intersect, then they intersect in a line. And I'm just actually going to add another point on this green plane right here. And I'm going to call that point, I don't know, Q or something like that. So here I could say plane RST and plane STQ intersect at line, line ST. There we go. A good way to think about the intersection of 2 planes is to think about where the floor meets a wall. Think about that corner at the bottom of where the floor meets the wall. That's kind of representing your line. So here's another good visualization here. If you think about a cube, right? Like that. So maybe we have the bottom of the cube. That's down here. You can't really see. I'm highlighting that. And then maybe we have the side of the cube over here. Where does the bottom meet the side of the cube? Whoops, I wanted that to be red. Let's try that again. No, it's not coming out red. Try it one more time. No, it wants to be yellow. Anyway, where does the bottom of that cube meet the side of the cube? Meets it in that line right here. Okay, so one more postulate to go and then we're done with this lesson. And that is 1-4. And it says through any 3 non-collinear points, there is exactly 1 plane. And that's really important because if you had collinear points, I'll give you an example. Think about that box again. You could have here's 3 collinear points, and those 3 collinear points are part of the top of the box and the side of the box. So there's lots of planes that go through collinear points. But if you have non-collinear points, there's only 1 plane that could go through them at one time.